welcome to this quick chat, which is part of Laser Focus World's Photonics Next event. I'm John Wallace, Senior Editor at Laser Focus World, and I'm talking with David Douglas, Senior Product Manager at Denton Vacuum, which is a company that produces thin film deposition systems for optical coating fabrication, as well as other applications. So to start, David, why don't you tell us just a bit about Denton Vacuum and its optical coating fabrication products?
Okay, thank you, John. Denton Vacuum has been around for over 50 years, founded by one of the optical pioneers in thin film coating, Richard Denton. So we've kind of been in the optical coating business since there was an optical coating business. We produce systems of all shapes and sizes, going from small electron microscope sample coaters all the way up to giant multimeter telescope coaters that you can see in the background here. And we do this with a high degree of automation and precision, and we're really looking for manufacturable solutions and bringing some of the benefits of semiconductor technology, high volume semiconductor technology, to the much smaller optics space, and benefiting from that automation that's been developed over the past few decades.
Okay. As for optics, some of the more difficult optics to coat are, of course, things like freeform optics and optics with steep curves and such. What are some of the challenges around coating curved and 3D surfaces with conventional physical vapor deposition methods?
Okay, so I have a small example here. This is a small hemisphere. Imagine you want to coat this uniformly. So same thickness on the sides and the top. There's a couple of problems here. One, if you use a standard planar sputtering target, which this is just a target, you're going to deposit at an angle here. You're going to deposit very well on this surface, but nothing over here. And it'll be less uniform on the top. Of course, you can rotate or you can move the target. That's exactly what happens in this giant system here to get uniformity. They move the targets all over the place. But of course, throughput isn't really a question on a system like that. You're trying to make one perfect mirror. If you're trying to do something in production, complex motion is very expensive and slow. And if you're using an expensive target for like gold, it's very wasteful. So it's really about cost and our cost of ownership of the tool. So getting the uniform coating is technically possible, but very difficult and expensive.
Sounds exciting. I think the next question that our audience would want to know is what emerging or future applications this approach can enable.
The approach that we use is we recently purchased IsoFlux intellectual property. And in that, we use cylindrical magnetrons instead of these planar magnetrons. And in a cylindrical magnetron, you sputter inward. So instead of going straight off the end, you're going in towards the center. And now when you take your optic and you place it in the center, it's getting sputtered on all sides at once. And you can add a little motion here if you want to really make the sides really uniform. But if you get it perfectly centered, which you can do with reasonable robotics, you can get really uniform films. Without rotation, we got less than 2% difference on a system optic like this, comparing the thickness of the top to the very edge, just by going in far enough. That's really manufacturable. That's something that anybody can do. You can put this on a very small system in any lab or any production facility. You don't need a giant 100-inch system. You don't need complex motion. You just need vertical lift. So that opens up a lot of possibilities. One of the things you can do then, if you had two cathodes and a way to move between them, which is, again, very simple automation, then you can put multi-layer stacks on a curved optic with very high precision. And that's what you need for optical filters. So imagine, that you have a Google self-driving car and a LiDAR dome. You want the infrared light to go out and come back, but you don't want visible light fogging your cameras. You would normally put planar edge filters, edge filters on there to screen out all the visible light, but you could integrate that right on the dome itself. And of course, there's military applications for this as well. Very interesting that none of us can talk about. But all optics based.
Yep.
But the Google self-driving car is definitely one where you can see the curved optics. Anywhere there's curves, you can now put filters directly on the surface and not have a planar filter in front of it, if that's important. And it just opens up a lot of optical design possibilities that aren't there before.
Mm-hmm. And it sounds like robotics, as far as the fabrication process, robotics is part of it. It's a key part of it.
Absolutely. So what Denton brings is as a system manufacturer, when we purchase the IP for the cathodes, is we already have a fleet of production-worthy tools, and we're able to integrate these cathodes with all our existing automation and controls and process feedback and SEMI E95 compliant software. That's already in the platform, and you add this cathode, which from a system point of view operates just like a planar cathode. You have power, you have gas flows. That's pretty much it for a magnetron. Mm-hmm. So from the system, everything's there, and we're able to automate it very easily and integrate it into our systems. And by customizing the cathode, the magnetron itself, you can put more than one material in there. You could do reactive sputtering. You can do very efficient mass conservation for like gold. So you get very efficient utilization of the gold. But the platform itself is already there and highly automated at whatever level you need.
Mm-hmm. So this, I've heard, is not a brand new technology on its own, but it's a new approach for coating curved optical surfaces. How long has the team at Denton Vacuum developed this technology to be used in production at high volume for these applications?
Well, this was originally developed back in the telecom boom for coating optical fibers itself. David Glocker was the inventor of this technology, which I'm sure many of the people listening know David very well. So he's been developing this technology for decades. Denton has integrated a number of systems with this technology, with these cathodes over the years, and we've delivered them to customers. The collaboration with Isoflux was always great, but owning everything yourself is much better because using all your own technology, you get to integrate it much more deeply, and you're not buying a component here, and two people aren't responsible for the results, system and cathode. So Denton's been working on this technology for quite a while, and it integrates, as I said, perfectly with our existing platforms, our Discovery and Versa platforms, either the sputtering single target, single module sputtering, or even a cluster tool with our Versa platform. And you can integrate these cathodes on the existing platforms and instantly get that great manufacturability and repeatability that you get with the automation. And that's really our strategy. We've developed these platforms, and now we have this great new technology to apply to a whole different class of applications. Mm-hmm. We're very excited about it.
One question I have is, 30 years ago, I was an optical engineer, and I remember the name Denton Vacuum back then. How long has the company been around?
So since 1964, I believe. Wow. So quite some time.
Okay. Before I was an optical engineer.
Yes, me too.
Okay. Well, David, do you have any closing remarks you'd like to make?
Yeah, so thank you for the opportunity to have this little chat, John. This is always a lot of fun to talk about technology with other receptive people. We're very excited about bringing this sputtering technology to these optics. One last point I didn't make earlier is a lot of these optical coatings are done with evaporation, and evaporation is great but it's very manual. It's very difficult to automate. So we're looking for ways to bring advanced manufacturing to these complex solutions that are typically not susceptible to this high volume manufacturing. And that's really a niche where we think we really have some real advantages. So bring us your challenging applications, bring us your complex curved parts that you don't know how to coat, you have ridiculous specs for, and let's see what we can do. Okay, very good. On behalf of Laser Focus World, I'd like to thank our guest, David Douglas of Denton Vacuum, for joining us at this PhotonicsNEXT event subsection
for this informative quick chat.